thank you so much for your hard work in organizing these things. And it's really hard to herd the cats like us, the speakers as well, and you've done such a good job. So applause to you. And thanks for pulling off yet another incredible space apps, this time power of 10. So 10 different countries getting together. And we'll talk about that a little bit. But first, let's get to know each other a bit. And I also wanted to shout out to all the speakers. And you have a judge for the Toronto section, who's Julie Claveau, who's from the Canadian Space Agency as well. We have Dominic here and Joseanne. So I've seen that the Canadian Space Agency is really, really involved in space apps. So I'm here to just build on that momentum from the Space Agency. I say this is you because I consider you all as data miners, explorers. We're all exploring this realm of what we can do with data. What is Earth observation data? And so that's you. And myself, Ishka gave me a little brief presentation there, but what is a Sun-Earth System Science Director? It is exactly what Ishka mentioned, is we really care so much about all of the interactions between the sun all the way down to the Earth. The scientists and engineers on my team are really passionate about saving the planet. They're passionate about the phenomena of the sun and how it affects the Earth that we live on. Auroras, giving you an example, and atmosphere, everything between us and the sun, our fragile atmosphere. And how do we protect it, and how do we get involved, and what's our value is in using satellites and even stratospheric balloons that you might have seen in some of the data sets. Different ways to use space to monitor and survey and also predict what's going to happen on this planet with that data. So I will go quickly through. I only have 15 slides, and I'm going to do some storytelling, and then please stop me at any time. I'm happy to take any questions or have any comments during the presentation. So I want to take you on a little journey. What I believe is the most promising and growing tremendous potential is data from space to protect this planet and this country that we're in. This is a beautiful 3D mosaic, and I think these kinds of mosaics can actually be made at space apps. It's kind of the art part of space apps, where you can take different color, put color on top of different 3D presentations of our country or any other place. So this is a beautiful rendition of a 3D mapping from our radar satellite. And the different colors sort of depict different altitudes and different materials and different surfaces on the planet. So I thank you for inviting me into your homes. I do believe that everything's been remote for this one again this year. Ishka, is that correct? Or somebody can nod. I can see Aditi. Is it everything's remote?
Yeah, everything's remote,
right?
Time. Yeah.
So thank you everybody for inviting me into homes in your little corner of our country. And I really want to take you on this journey that I will hopefully conclude by having you understand what EO is. So it's an EO 101, Earth observation. You could walk away and say, I think I understand what Earth observation is. At the Canadian Space Agency, it is our mandate to promote peaceful use of space. And we do that to build knowledge, and we work space science, technology, and work towards social and economic benefits for Canadians. And I'll talk about that a little bit, what that really means. So let's move on. This is really, truly one of my favorite images. And I love to start with this image so that we all feel like we're in the same kind of space. This is our country, and we see it from a satellite in that image. I also want to invite you to the Canadian Space Agency. This is what it looks like from above, maybe from a drone shot. And those of us who work here, we feel a little bit like we work in a spaceship. You can see it sort of like, it looks like a bit like a spaceship. And when I was young, I was your age, probably some of the listeners, I knew that Canada was starting a space agency, and I said, oh, I'd love to work there one day, either as a scientist or an engineer. And here I am today doing exactly what I dreamed of doing. The space agency was established in 1989. I think I learned about it in the early 90s. And so that building is filled with 600 scientists, engineers, and other passionate people who enable our work. And a few of them are on the line with you right now. So here we are just outside of Montreal in Saint-Hubert, Quebec. And that is the Canadian Space Agency. There's only one in Canada. You know, in NASA, they have lots of different centers. In Canada, we're mostly based in Saint-Hubert with a policy shop out in Ottawa. And I'm going to one slide about me so you can get to know me a little bit. That's me in the back with a group of engineers when we were building rovers to prototype for going to the moon and to Mars, not the moons, the moon and Mars. And it was great moments in my career where we actually got all of the equipment out of the garage, put it out on the Mars yard out behind the space agency, because there was a visit from a minister who said, I want to see it all at once. So it was a really great moment. And I remember everyone was driving, everyone picked one of the rovers. We knew how to drive them all. Everyone grabbed their rover, they were driving them out. And my little Mipser rover wouldn't drive. And I was so mad, and I was trying to reboot, and the minister was coming. So I picked that thing up and I hauled it out, plunked it on the top of that little hill. And I remember laughing that day that things don't always go smoothly. And that's a big part of our job, is problem solving, being creative, trying different ways to do things. And if not, brute force always works. I dragged that rover out there that day. So it was a really, really proud moment for us, because we kind of consider those rovers our babies. Each of them have a little character. Some of them are naughty and we don't get along with them in some ways because things don't work, or some of them do amazing climbing and perform really well. We also have these optical systems that we use, and we can map as we go. So there's a lot of cool systems on board. This isn't just about the number of wheels you see. It's also about the intelligence inside those rovers and the data that it collects, so that on Earth we can take that data and understand better the planets. So along the bottom, I'll tell you a quick story about me. When I was young, I loved the idea of astronomy and the solar system, and I thought, I'll probably become an astrophysicist. Then I got to McGill to do my bachelor's degree in physics, and I said, I think electrical engineering is even cooler. So I did my bachelor's degree in electrical engineering, but then I went to California and I did a master's degree in space science, which was more like astrophysics. So I got to balance both worlds, and today I really work with both scientists and engineers. I had a great experience moving out to Germany, working at ESA for a few years. And the last little icon shows you, I ran my own startup company. I tried something, building hardware for voice systems for control centers. So when you hear, Houston, we have a problem, that has to be perfect voice signals. And I had the opportunity to run a small company in that before I joined the Canadian Space Agency. And now I will talk entirely about what I do at the Canadian Space Agency. In the beginning, it was robotics. I worked on the Dexter, the robot, and the space station. And now I'm very, very committed to something. Instead of looking out at space and exploring it, we look down at the planet Earth. And that is what this talk is about, is this newfound passion for the whole other part of the Canadian Space Agency that looks back down on Earth. And we will talk all about that very rich data and why it's become so, so important to me. I wanted to get to know all of you a little bit better. So I went out to look at the Space Apps Challenge for this year, and I looked at all the Canadian Space Agency challenges that were put out. Some people chose these and some people didn't. They chose the NASA challenges. But I just wanted to point out that Alouette, Cassiope, RadarSat, SciSat, NeoSat, these are our rough and tough satellites that are in space right now, and they're collecting all that data, and you're using that data through space apps to do discoveries of your own. And they're really, really incredible, each one of them. They have sort of their own little superpower. I'm going too quickly. I will get to talking about our satellites just for a minute so that you can appreciate that we have these superpower satellites up there, and each of them has its own mission. Each of them has something specific that it needs to give as data back to us so that we can do great things with it. And I want to open your mind to, yes, Space Apps is this first look that you have at the data, but there are so many possibilities, not only now, but going into the future with data. I looked into what you're all doing. So I found 17 teams in Toronto. And I was just asking at the beginning if anybody was on these teams, because I also looked at what you chose as your different challenges. And I'm amazed to see so many people are choosing Earth observation related challenges. So I thought maybe I could build a little bit of your appreciation for that, what's behind that, and why it is so important to the work I do every day. So I just loved some of the team names like Cougar or EarthML. Astro, the Martians, Trash Men, Shooting Star, Moon. I think it's super, super fun. So a shout out to all of you who are working right now on the Space Apps Challenge. And any of you who see the recording later because you couldn't make it to this talk because you're hacking away. We all understand that you're focused and you're being productive and you can't be here right now. So hopefully you'll see this video and you know that we are all cheering you on back here, right? Team, we're cheering them on. Everyone's nodding. These are our little superheroes. These are Canadian ones that are all around the planet. SciSat's over on your right, and some of you might have chosen the SciSat data set. And my own colleague, Marcus Deschmek, he supports all of the teams that grab that SciSat data. I'll talk about SciSat in a minute because I picked two of our satellites to talk about, one slide each. RadarSat, the one in the middle, it's really the niche for Canada. It does 3D mapping. Its superpower is to send down active waves. When they rebound, it can map out the Earth and all of its topography, all of these surfaces in 3 dimensions. Canada is so good at this that we built RadarSat-1. We worked with a Canadian company to build RadarSat-2 or to enable RadarSat-2. It's still running and you see it right in the middle. And then the 3 little brothers over on the left were just launched 2 years ago, RadarSat Constellation. So all 3 of them spread out and work in teamwork, and they map the Earth every single day. And when I used to do these talks 2 years ago, I used to say, they're going to launch soon. They're launched, they're operating, and they're sending down incredible data every day. So I picked 2 of our science satellites that I want to talk about very briefly because their data sets were part of Space Apps. So OSIRIS, which is the name of an instrument, on Odin, a Swedish satellite. My question is to you, did you understand or did you know that a 20-year-old satellite like this one, 20 years old, you might think 20 years, is it obsolete? Is its data not important anymore? In fact, anything that's collecting climate data is more valuable the longer its history is. So this fabulous satellite that's 20 years old is collecting an incredible timeline of climate data. And this year is the first time we've opened that data to the Space Apps, prepared it and had it ready to be open to you. I believe that's true, Josiana. You might want to put in the chat if that's true, but I think it was the first time that we've made this available. And it is a phenomenal stratospheric ozone data set. And ozone, when I was a kid, we were all so worried about the depletion of the ozone. And there's been a lot of correction of the ozone over time, but now we're noticing again, I believe the latest discovery is that over Australia, after the wildfires last year, they've have a new hole in the ozone that was detected using OSIRIS, SciSat, other fusion of data. So I think that the name of the challenge that was involved in this one was detect and quantify the ozone recovery in the stratosphere. I'm just trying to move the banner to see the name. It was leveraging AI and ML to monitor, detect, and quantify ozone recovery in the stratosphere. That was the name of the challenge, that some of you picked. And I just wanted to applaud anybody who dove into that challenge. I'll be very curious to see some of the findings that you had and the ability to bring a few data sets together. This one sounded challenging to me because it suggested that you use not only OSIRIS, but some other data sets as well. SciSat, so you can see SciSat, our little satellite in the middle that's going around Earth. And I chose, instead of showing you just a picture of the satellite, to show you some of the incredible statistics that Marcus Deschmek always puts together for everybody to better appreciate the contribution of a satellite to what we do. So let's look really quickly. It was launched in 2003. So this satellite is 17 years old. Also, that is remarkably mature for a satellite. But again, for these climate collecting data sets, the timeline is really valuable to us, that it's going all the way back to 2003. So we talk there about its inclination, how high it can get across over the planet, or up how high up the Canadian latitudes it can get. 30 publications per year with 100 institutions like universities involved. Look down in the bottom right corner. it can detect 66 trace gases, which is really phenomenal. And I think that number has been growing over time. The taking in a satellite and discovering that it has new uses and additional abilities that we never expected when we first launched it or when we were first designing it. So it's up at 650 kilometers. To you, what does that mean? Let me give you some references. The space station is at 400, so 650, that's quite a distance. That's not quite the distance though from here to Toronto, from Montreal to Toronto. So really, in the end, it's not really that far away. It's quite close to the planet. So that gives you a good feel for SciSat, and I'm going to check and see what the challenge was called. It was called Pollution Spills High Above Us. SciSat helps a team of Canadian and international scientists improve their understanding of the depletion of the ozone layer. And this has emphasis on changes occurring over the Arctic. So I'm just reading off what the challenge was that you could have jumped into. And really, really happy to see two of our rough and tumble satellite data sets involved in Space Apps this year. Who are we serving with our data? You might be asking that question. What do we do with data? Well, the data serves all Canadians, and we really try to touch on not only the traditional uses of it for farming, for understanding our climate, our atmosphere, we're able to monitor forests and changes in ecosystems. I'm going backwards across the images here. Weather, this is down on the bottom, of course. Data from space is important for weather. And the beautiful image that I had at the beginning that shows us, gives you a feeling for always surveying our planet, our country and our planet, but importantly, being able to predict what's coming next. You hear words like climate change adaptation. How can we adapt for what's happening next? Pierre Langlois, I'm really happy you're here. I just saw some newcomers, and I've been calling out some of the people on my team who've been enabling the data sets and the work that we do. So Pierre is one of my super scientists and engineers who enables all of this work and helps us serve Canadians with space data, which is what that touches on. So now I'm going to blast through a number of images. As I said, we predict the future, and I just wanted this image actually represents a video I'd like to show at the end. It's a little bit challenging for me to show the video in the middle of my presentation. So if I have time at the end, this video was made to really talk about how data is enabling everything for protecting our planet, and we really want to encourage you all to see the future. This is all of you in the future, all of you who are starting with Space Apps as perhaps your first chance at touching space data, but we want to encourage you to be the great minds that enable open so many doors and discoveries for the next generation. The other question about why do we do this? Canada is part of a much bigger global initiative, many of them actually, but I'll touch on one. If you walked away from this presentation and you could talk about the United Nations Sustainable Development Goals, there are 17, and space data enables over half of them. Half of them, in order to meet the indicators, they require space data in order to meet some of the targets and to understand the indicators that will show that we are making progress and improving. So if there's one takeaway from here, why do we use space data as Canadians? We serve Canadians for this previous slide I talked about, but we also enable our obligations and our commitments internationally as a country at places like the United Nations. So let's do just a quick overview. This is just a beautiful eye candy discussion about, as I said at the beginning, the whole solar terrestrial part of what I was discussing earlier. I mentioned auroras and the impact that they have on the planet, and we've been talking more. Pierre's online, and Pierre and I have a lot of discussion about how even radiation coming down from space might have an impact on climate, and we're looking for new discoveries and new understandings of how solar activity impacts the planet that we know and love and live on. A lot of us look at auroras and they say they're beautiful. Yes, they're beautiful. They're also an indicator of incredible levels of ionization and activity that happens in our upper atmosphere, and potentially poses problems You know, a major solar flare can cause major infrastructure damage. And I'm trying to remember if it was in 1984 that it took down a lot of communications and electrical grids. And Pierre, if I've got the year wrong, you can chat that and remember what year that one of the major solar flares took down a lot of infrastructure. So we're working to understand it much, much better so that we can be prepared for the next major cycle that I think is coming up in 2025. Pierre could do a whole talk on that. When we think about ice extent and ice melt, our satellites contribute to understanding the thickness of ice, the extent of the ice up north. So when you think satellites and what they're looking at, what they're observing, think about our polar bears and think about the ice up north. Think about navigation routes and safety, maritime waterways, and the ability for us to know if it's safe passage. Think about coastal erosion and the impacts of climate change on our coastlines. If you had a house built on this coastline, you would not be very pleased with the picture that you see right now. And think about modeling and prediction. And this is sea currents and Environment Canada. I didn't mention all the other departments that we work with, but I'm going to do a quick shout out to the other government departments at the federal level that we work so closely with. So Environment Canada, Natural Resources, Agriculture, Department of Defense, Department of Fisheries and Oceans. There's a great collaboration between all of us for using our space station for doing predictive modeling. And Environment Canada has some of the most powerful computers in the federal government for doing these kinds of modeling. I think this comes from one of their supercomputers, what we're looking at right now. And oil spills. Of course, if there's major disasters, the Canadian satellites come to the rescue, not only to help but to find safety routes for teams that go in. You can imagine if there's flooding and teams that need to go in and to help them safely access some of these mitigation activities that happen. We're part of an international charter. And just imagine when a disaster happens anywhere on the planet, all these satellites point their eyes right down to where the disaster is happening. And we work together collaboratively to mitigate those disasters. And one of the, Dominique Poulin, who's online, is part of the Smart Earth team, Utilitaire, and she's so proud of it with great reason, which just kicked off a few years ago. What the objective is of Smart Earth is to take these grand challenges. A challenge like, an example, the Department of Fisheries and Oceans telling us, can you help us protect the whales and help Transport Canada ensure that the boats can safely navigate around the whales? And that is not an easy thing for a satellite to do. But right now it's only being done with drones, some citizen science, detectors, sensors underwater. We need the satellites to bring another angle, like literally another angle, especially when whales disappear for days at a time and then they reappear somewhere. That might be the piece of the solution that satellites can contribute. So when they asked us if we could help, Dominique's team went out to all Canadians and said, here's the problem statement. Here's the problem we're having. What ideas do you have to either survey, monitor, or predict where those whales will be so that we can come up with a solution space? And it's a very cool way of doing things. You ask all Canadians, and any groups can get together. They can make collaborations, consortiums, you might call them, which would involve universities and high-tech companies and students, and bringing all together to come up with an idea. And we give them maybe a year to come up with a concept, and then maybe more time to prototype that concept. And ultimately what we hope is they come up with an operational system that can plug into that solution. All of these competing priorities for Canadians. Finally, what's up and coming? A Wildfire Satellite that our teams here at the Canadian Space Agency are exploring. I have this amazing statistic. Did you know that approximately $1 billion is spent every year to combat wildfires in Canada? And a specific example is the Fort McMurray wildfires in 2016. And it's an example of really costly devastation. That was $9 billion all told. So Canada is working with Natural Resources Canada, they're the Canadian Forestry Service, and we're working on developing heat detection sensors. They're called microbolometers, and they will hopefully really contribute to the monitoring, the management of these fires, and they will fill a gap that we have right now, because you can imagine they have a really complex system of how to fight these wildfires, but satellites can help come to the rescue. So hopefully stay tuned. In a couple of years, you may hear about the launch, and then things will get really exciting. You might be asking yourself, and this sort of is a segue, sort of a shift in my presentation to say, what's in it for you? What can you hope to do with space data in the future? So I took 5 minutes, I went online and I typed in space data to drive apps. And this is what I came up with. So I found one called Snap Planet, and it says, create and share pictures of the Earth from space. Great. So this small little group of people put together an app, and I'm sure it's really highly inspiring. The next one, air quality in London. A group of Londoners put together this app, and they can check air quality at any point in time. I would love one from Montreal, and I should probably check if there is one, but it is something that we are very preoccupied by. And there is a business case to do air quality measurements in cities all across the Earth. Did you know I saw air quality measurements in surprising areas? You might think that great big dense cities like Tokyo or Beijing might have some of the worst air quality in the world, but I found out that Salt Lake City has the worst air quality this month because of wildfires and because their population's grown too quickly, and suddenly their population has become obsessed with air quality. And if that app that you built was able to be transported around to different cities and you could sell it on different platforms by just grabbing apps from different satellites, you win. You've just developed a highly valuable app. You have to think about the future and what people care about. Another one, building radar search for construction projects worldwide. Very interesting. Down in the bottom left, Discover Air recommends an optimal time to visit Greece and Cyprus, given their temperatures and air quality. So before I go visit Greece again, I might want to know that the air quality is good at that time of year in general, or right now. That's a really interesting app. It's driven by tourism. And the last one right here in the middle is Wave, is your climate aware, voice controlled city assistant for Vienna. Where can I swim? Where's the closest metro station? Very fun, very great ideas. That's how you can see yourself in the world of apps that use space data. Is there really a market for me to do a startup or do a company in the space industry in Canada with space data? Very quickly, over 100 companies use satellite data, but 2,450 use geomatics, which is all about the localization plus the space data, which is probably what most of those apps are that I was just discussing. And the commercial sector, end users are like, you're asking yourself, well, who's using this data? Right now, the biggest users are energy, resource extraction, construction, defense, urban design, designing cities, transport planning, and agriculture. So that gives you an idea of where the space data is currently mostly being used. And this picture is the ecosystem in Canada. And every one of those logos represents a company doing great things. And the number of companies that are emerging is amazing. Dominic Poulain, who's on right now, could talk about how many new players there are in the Smart Earth program. How many companies who didn't think they were space data users, they were just data users, decide they'll go grab their data from satellites, and suddenly they join the space data companies that we call Canadian. So it's a very, very exciting field. And I think I'm getting close to wrapping this up. I am, your key takeaways. So data is a gold mine, and your generation, we expect you to do great things with space data. And this weekend is just a start for you. So now that you're part of the SpaceX global community, put it on your CV or your resume, whatever you want to call it. If I were looking at a resume and I saw that you were involved in this, I would want to ask you all about that. And I would consider you a pretty remarkable candidate. Find a role model from this weekend. Anybody that you might have worked with or that you might have seen talk, you might have witnessed talking, or go onto the NASA site and see how many people were engaged in this from, well, 10 countries that were leading it, but many more who were involved. And finally, stay curious, join everything, do what you did this weekend. It is absolutely the best way for you to ensure an exciting career and future in the use of space data. And that's it. I would love to open the mics. I would love to have any questions or comments, but even equally importantly, I'd love you to tell me if you were on a team, what team, and maybe what some of your experience was using space data this weekend. Thanks, everybody. And if for any chance we don't have a lot of questions or comments, I am going to play a video to finalize the presentation.
Yeah. Hi, Taryn. That was a really amazing talk. Thank you so much. I did have a question. So you mentioned the ozone problem when you were young, and I think it was the Montreal Protocol that addressed this issue with a lot of success. So how do we do the same with, the carbon emissions these days, and how do we promote the same sense of urgency? And I guess also, how close are we to the point of no return?
Oh boy, how close are we to the point of no return? We see a lot of really scary numbers right now, don't we? And we see, we really exercise our power with our vote. Some of you are just becoming voting age. We definitely want our government to be audacious, to be ambitious about meeting these protocols, and any of the climate action that's happening. The COP26 is upcoming. We at the Canadian Space Agency, we are on the edge of our seat just to provide our government with all the data they need. That is our job. And so in my world, it's being ready all the time with those statistics. You saw that SciSat. We are constantly on the edge of having the best information, bringing together advice. We'll give advice to our government and make sure that they have the most up-to-date information. Our job as public servants is to give that advice. And we don't do it just with Canadian satellites. I think I was clear that the more we bring fusion of data together, the more that we discover, that the more that we are really able to provide the best information. So we're information providers, Ishka. That is really our job. But all the rest of you out there, you actually have the ability to go develop those new apps and make discoveries. And actually, as we say, you're gonna move the needle. You can move the needle because you're the ones hacking. You're the ones who are out there making the change. You are the change, and we're really looking to all of you and your generation to step up and enable these things. So our team's putting those instruments, those powerful instruments in space for you. And we look to you to help us get the best information from those. So I think from where I sit, that is how we contribute. There are so many possibilities moving into the future of how we can do this better. And I will also mention Dominic, who's online. The program Smart Earth is using all Canadians in the solution space. So we throw the problem out, and the problem can be climate change and climate change adaptation and things that are related. In fact, one of their challenges was the Sustainable Development Goals. How can we move the needle on those? We're not here at the Canadian Space Agency prescribing how to do that. We're actually here to launch the challenge, launch the problem, and then Canadians work together to respond to those. So I think that's from where I sit, how I see the Canadian Space Agency really enabling the answers to these questions. And Julie is online. Julie, I did a shout out to you earlier because you're a judge in the upcoming judging for this group in Toronto. And thanks for being here. She's waving.
Yeah. Yeah, and I see Dominique has her hand up.
Taryn, I would like to add some element for a question from Ishika, is that right?
Yeah, Ishika.
Please. And Pierre too, if anybody wants to add some elements, I would be so happy to use my team since they're here.
Okay, perfect. Well, I would like just maybe you asked about like how to promote the urgency of the carbon challenge at the moment. And I think when I've been working in the environmental field for the past 20 years, and one key element that is covered through my career is really to get to know a little bit more about the policy. So there's so many laws in place in Canada, and this is something that we don't learn much at school, not even during my bachelor degree and my master degree. And I realized that like the influence of citizen about like sharing your value and saying out loud like environment is important. Sometimes we don't see like the change right away, but laws are put in place. So there's fisheries law, you have the Canadian Environmental Protection Act as well. And in the past couple of years, there was lots of investment with Justin Trudeau, and he invested a lot on the Ocean Protection Plan, and some good positive impact of that was the creation of new laws as well. So the most recent laws that has hazard in it for the environment was launched in 2019, which is the wreck hazardous abandoned vessel. So it was one way to clean our water. So it's not per se related to carbon, but just to show you different example. And if you're interested more about like how you can influence yourself, well, start learning about the laws. It might be difficult at first to read it, but there's probably some way like to get to know a little bit more, and how law officer apply those laws, and then it's generate some influence movement to find solutions.
I appreciate that so much, Dominic. And it goes back to my takeaway. Be curious, stay curious, inform yourself. I love that.
Thank you so much, Taryn and Dominic. That was really helpful.
Does any of my colleagues want to speak up at all? Pierre's online, Josiane's here.
Hi, Taryn.
Pierre, so happy to have you online.
Yeah, congratulations for that speech. There's a kind of speech I like to hear, so I'm available if there's any questions, of course. But I think you did a great job. So just in case, I'm here.
Thanks,
for you.
Pierre. That's great. If there aren't other questions, and of course we'll give another minute for them, but I would just finish off by playing a video, and everyone could drop off at the end of the video. If I can make the video work, of course, because there's always challenges of making video work with audio and whatnot. Or if anybody wants to even open their mic and just say something about when they looked at the data sets this weekend, or when they looked at the challenges. What was the most interesting to you? Like, which data sets did you choose and why? I'm really curious to hear back from people, because we work in a bit of a vacuum. Pierre and Marcus and others got these data sets ready for you. And then maybe your anybody's feedback about whether they found those stimulating, too challenging, and even the organizers. The organizers saw the list of all the data sets. I'd love to hear perspectives. Everyone's shy.
I can do something. I participated too.
Julie, you're there.
Hey. Maybe I can get the ball rolling. So yeah, no, I actually did one of the challenges with my kids. So I thought it was super interesting. It was actually, I think one of Dominic's challenge that she created for CSA. And it was super interesting for me to be able to share with them, what we do at CSA and what the RADARSAT constellation mission looks like. So we didn't use any of the data per se, but we did use some of the images and what it looks like, and some of the text that is on the CSA website. So it's super interesting, just even at their young age, for me at least, to see and share that information with them, because everything is new, right? And often they ask questions that I wouldn't even have thought about, and it allows me to explain to them what things mean. So just having, the forum in terms of space apps to be able to explore those and get to touch, things that data that we've never touched before, and think outside the box and create something and share it with other people, no matter their age or their background or, their diversity factor. It's super interesting to see the different questions people will have. And when we come together from all these diverse backgrounds and we use this data, solutions that we can propose become, out of this world, because, we pull all those strengths together. And yeah, so I'm really enjoying participating, as well as, judging later on, which I won't be judging my kids. It'll be in another town that they'll be doing their thing. But yeah, that's what I think. So hopefully somebody else can share their experience of the weekend.
Yeah, I would love to. Robert was asking, can the question be repeated? And I want to repeat. I'd love anybody's perspectives on the challenges that they saw, whether or not you found the challenges exciting and stimulating. And I want to encourage everybody to open their cameras right now. It helps us to see everyone. Yeah, that's the question. It's just anybody's views, or were there ones that looked more enticing than others? And CSA had 7, but there were others from NASA. And I think Canadian companies like Wyvern and Skywatch, by the way, if you want to learn a lot about EO, go on Skywatch's website. I believe they were winners of space apps way back in the beginning. Josiane, can you tell me if that's true? Skywatch might have been, some of the Skywatch were winners of space apps. Is that true?
Yes, I think in 2015 or 14. They won a space apps.
They won a space apps from Waterloo, and now they have this crazy company. I say crazy because they are so talented. I go on their website to learn about what's happening in EO, and the president, he has a tendency to do newsletters, and so I can read about what's up and new and who they're working with, and it's a phenomenal website. And apply to Skywatch one day, because it's kind of that if I could go back and do things differently or do things again, I would probably end up in that domain with companies like Skywatch and Wyvern. Wyvern's all about use of hyperspectral data for the use. They are hiring. I was there. That's phenomenal. Of course, because they are so successful, they're probably always going to be hiring. Look at the kind of profiles of people they're looking for. I looked at the kind of people they hire, and their hiring is a lot like sort of SpaceX, where it's really fun and they talk about the person. They want to get the culture going at Skywatch. I'm a huge fan of the company. They don't even know that, but I am, because their website's actually incredibly educational, and they treat the whole team as a team. They don't have like these hierarchies. They're just one big flat team, and they're all featured on the website. I can't tell you how good their website is. A great place for you to sort of springboard from this talk and this weekend to how you can find out more. Go on Canadian websites of Canadian companies like Skywatch and Wyvern to find out more about the use of space data for the benefit of Canadians. They're all about agriculture and making things better for Canadians, or improving the outcomes and the lifestyles of Canadians. So if there was anybody else who wanted to give us a perspective on what they thought of the challenges that they saw this year.
Yeah, I remember Robert mentioned that he was helping out with a couple of teams. How's that been going, Robert? I'm interested to hear about that.
For me personally, I thought the challenge, since it's my first one, I thought it was going on for a few months. So I had a rude awakening when someone said it's only 2 days.
Yeah.
But yeah, the condensed time, just 2 days, is making stressed and kind of like a chicken with your head cut off.
That's okay, right? Because in the end, there's no objective. They have to complete something as much as get their feet wet, right? I think just touching it and feeling like you have opened a door to what these data sets are, I think is a great start. But I don't know, I can imagine if I read one and I had to pick one, I'd find it pretty daunting, really. They're really ambitious.
Yeah, and I think the even bigger part is the collaboration aspect of it. So it's really interesting, Robert, to hear that you're collaborating with all these different teams and meeting new people.
Thank you for doing that, Robert, for engaging and enabling the teams.
Oh, for saying that.
Great. So I will call the talk to a close, and it's a 1-minute video, and it just will leave you with a good feel for use impact Canadians. So what I need is somebody to give me like a thumbs up or something if it appears to be working. I'm going to try it for 3 seconds. I'm going to pause, and then somebody's going to tell me if it's working. It's not only, I'm trying to get the audio working, but at least the subtitles will definitely work. So let me try sharing my screen, and let me try going over to the video that I have queued up. I'll go to my screen one. It might look a little bit confusing to you for just 1 second because you'll see yourselves. And then I'll pop over to the video. Okay, so I'm just going to play for a second, and then I can see Julie and Aditi. So you're just going to give me a thumbs up if you can hear it.
It's not very loud though.
Yeah. Not very loud.
Taryn? No, she can't hear.
Just 1 second. I'm going to see what I can do for increasing the audio. Does anybody know? No.
No.
Okay, well, I'm just going to have to go with it, I think.
And Taryn, if you could
Yeah.
share the link in the chat so people can watch it after on their own.
Yeah,
computer.
great idea. I'm going to do that. Okay, just back up a couple seconds and here we go. All right, here comes the link, and I want to thank everybody one last time. Thanks so much. Have a great weekend.
Thank you, Taryn, for your lovely presentation, and thank you for CSA people joining us, and thank you very much for being so encouraging to our participants. I wish the participants all the best with hacking on the very last day, and please do join us for our next talk, which will be at 1:30, so just half an hour from now.